disposable ECG network. So ideally, in our case, how we will record? So for recording lead to ECG, we will attach 3 wires actually. So one wire will be a ground, which is connected to the right leg. So for demo purpose, we will connect it on the right leg itself. But ideally, you can connect it right side of the abdomen. And other two lead wires, positive and negative, we will connect it on the positive will be on the left leg and negative is on the right arm. So the positions will be like this. So right arm, right leg and left leg. So I will be connecting for the demo purpose. I will be connecting on the here, or we can connect it here. Debris or any this thing will be removed for a better, cleaner ECG. And ideally, the subject will be in the supine position. Just for a demo purpose, we are connecting it where the subject is sitting. And also, we wanted to connect the entire setup to projector also. So this is not feasible. So we are connecting here. But ideally, when you are doing the heart rate variability, the subject should be on the supine position, and the subject should have taken proper rest before we start the recording. Otherwise, that will influence the heart rate variability. So these things are your protocol. And the negative electrode on the right arm. We will be recording the ECG signal. Don't worry about the channel or why it is not. But it is reversed. We haven't done any processing of the signal actually. So there are a few things important here. You can see the range we have to set, the filter we have to adjust here, and we have to set the main filter also. So basically this main filter, once I apply, you can see the baseline noise is removed almost. So this is very important. This main filter is very important. This will remove the environmental noise. So we have various power sources here which uses the 230 watt power source actually, which will have the 50 hertz frequency. That is what actually most of our noise is. So once I apply the main filter, you can see the ECG is very clean. And if you want further, you can do a low pass filter. So I think Madam was mentioning she wants to apply the digital filter, actually band pass filter. But before that, we use the hardware filter. So don't worry about the digital filter part. So digital filter is nothing but the filter applied at the software level, not in the hardware level. But whatever adjustments we are doing here, this is at the hardware level. So this is very important. We should not over filter or over process our signal. Our purpose is we want to make sure we are retaining most of our ECG qualities of the signal actually. I will show you, see, without applying the filter only, this is very good. But if you wish, you can apply a 50 hertz filter. This will not make much of the changes here because the signal is already very clean. See, Madam was talking about 35 hertz. In the hardware, there is no 35. Below 50, there is only 20 hertz. What if I apply a 20 hertz filter? So usually the ECG signal will have the frequency band of about up to 35 hertz. That is why she wanted to apply 35 hertz band pass filter. But if I go below that, if I will show you, I am applying 20 hertz. You see how the signal looks like. You see the signal now, and you see the signal after applying the 20 hertz. So what happened here? What happened here? You can see the difference So what are the changes? This side 50 Hz filter, this side 20 Hz filter. What is the main difference between these two? Amplitude change. You can see the amplitude here is slightly higher, but here it is reduced. But signal is very clear. And sometimes for maybe some other subjects, if they have other components actually above 20 Hz component, then all the frequency components above 20 Hz will be removed. That is what we are filtering. And when I apply a low pass filter, the equipment will allow the frequencies up to 20 Hz only. Above 20 Hz we are not allowing it. We are not at all recording. That is what the low pass filter means. So it is very important you don't over filter the signal. And another thing is you have to set the range properly. So currently the default range is 20 millivolt, but this range refers to the amplitude of the signal. So what is the amplitude of the signal here? So this is about 1.2, 1.3 millivolt here. So the range should be maybe twice the maximum amplitude. If we are expecting around 1.5 volt, maybe for this subject it is 1.5 volt, maybe for some other subjects it may be slightly higher or lower also. So you have to always consider little higher. So I am expecting maybe it will go up to 2 millivolt, so I will set 5 millivolt as my range. All these things are called as settings, making a settings. So once I make the settings, I can connect any of my subject and I can start recording the data. This is clear only for the first time. This is called processing the signal or conditioning the signal. So why we have to set the range properly? See, we have something called resolution of the device. So we have 16 bits resolution. When I say 16 bits resolution, whatever the range I am setting, that range will be divided into roughly 65,000 data points. And if I am setting 5 millivolt, for the 5 millivolt also, same set of data points, 65,000 set of data points. So when I apply the range appropriately, my resolution will be increased. If I am setting higher range, the resolution will be slightly lower. So that is why it is important you have to set the proper range for better resolution of the signal. So these things are very important when you are recording at higher quality or if you want to publish it higher index journals. These things may be very important. So I will set 5 millivolt range and I will apply a low pass filter of 50 Hz and I will switch on the range filter. So these three are very important. And you can see the ECG is very clean. We have the ECG recording coming in, but I have two more channels which I can use it for calculation purpose. So I will use heart rate in channel 1. So you have various calculation options here. So currently there is no calculation applied. I will use cyclic measurements and I want to calculate the heart rate from ECG, which is in channel 3. I want to calculate the rate and my signal is ECG human. So I will set the preset also. And for verification, I will this is called even markers, the small circles on each of the R rate, which means all the R rates are properly picked up. You can cross check for some more beats also. It is perfect. If this is not perfect, maybe I have to slightly adjust this peak height. And if the preset is not proper, please calculate the R as well here. Go to same cyclic measurements. Again, my source is channel 3. Now I want to calculate the period, the interval between the R rates. And rest everything else is same. ECG human, I will remove the human marker. You can verify here. Click OK. And you can see the R interval is visible. So now we will start the recording. In real time, we will be seeing the heart rate and the R interval changes. 5 minutes, minimum 5 minutes. but ideally you can record for a little longer time. If not, in case in between any artifacts or anything, or maybe a that is one call. So we have 2 blocks recorded, and we have taken log 2 for the analysis, and start and end time is 0 seconds to about 3 minutes 10 seconds actually, and total number of beats are 175. All are normal beats we have included. Actually, we have excluded one. So now, so one we have excluded actually, which is not reflected here. So then we will get the time domain statistics here. So time domain is our statistical measures like average, median, mean, standard deviation, and these are very important parameters: SDSD, RMSSD, and PRR50 or NF50. So these 3 values are very important. We will usually use it for reporting purpose. And this is our currently. I will just clear the analysis here. So now there is an option here. You can see analyze wide sampling. So if I enable this, all this analysis will happen in real time. So I will just start the recording. You can see these are populated here. So this is real-time analysis. You can have a look at all your arbitrary variability parameters in real time. And for the expiration, the amplitude will decrease. So this is the respiratory pattern for the subject. From this we can calculate the respiratory rate as well. Per minute how many respirations he is doing, that also we can calculate. The same as like how we calculated the heart rate or RMO from ECG. We can calculate the respiratory rate from the respiratory rate. And the same thing we are going to use it for the deep breathing to calculate the RR heart rate. During the inspiration and expiration, we can use the same rate. So you can see next step. So we have marked the second to standing position here, and this is the RR interval before and after. So from here we will take. So you can see from here I am moving my cursor here. So I have placed the marker here. So this is around 15th beat where the RR interval is low, and around 30th beat we can take somewhere here, which is RR interval is 8. If you want to calculate, so here the RR interval is 0.886. So here it is 1.065. So from that we can calculate the ratio. Any notes? See, this is completely manual. Maybe we can create the settings for this also, and we can extract the information somewhat automatically. That is also possible. Especially the deep breathing. These are normal breathing, and you can see clearly the deep breathing. So if you are recording the respiratory waveform, we will understand whether the subject is doing the deep breathing properly or not. So from this we can even calculate the timing. We have the timing here, approximately if it is taking 10 seconds, all the things we can verify here. Even though it is not 10 seconds, fairly this is okay. Especially here you can see these are very short. This is not for 10 seconds only. But we cannot expect very good recording from all the subjects. He is fairly good, but all the subjects may not do the same. So we will just stop the recording. So here you can clearly see these are the 6 deep breaths, 1, 2, 3, 4, 5, 6. And accordingly we have the heart rate and the RR interval changes also. So when we start at deep breathing, you can see the heart rate is also changing in the same fashion. So from that we can take the, whether you want the RR interval or heart rate, whatever, you can extract and you can calculate the ratio. So we will take the RR interval. So we have something called the data pad. So I will take the, we have heart rate, I will change it to maximum heart rate, and in the next column I will take minimum heart rate. Sorry, RR interval. So I will select each of the respiratory cycle here. You can see this is the first cycle. I will add these 2 data pad. You can see this is adding these values. Respiratory mean, RR maximum, RR minimum, RR mean. So talking about these values, we are focusing on RR interval maximum and minimum values. So I have selected one cycle actually, first cycle, respiratory cycle from the deep breathing, and for this particular portion, it will extract the RR maximum and RR minimum. You can see the RR minimum just before starting the debriefing, and RR maximum is taken at this level, which is displayed here. So minimum is 1.018 and maximum is 1.15. So if you want, you can always calculate the difference also here. And I will have to read that. Then third cycle. I have to read that. Fourth cycle. I have to read that. Fifth cycle. I have to read that. Sixth cycle. So now we have 6 set of values here. So here we can do the calculation here. This is something like our Excel. And we can calculate the average for these values. Same way from this also. So the ratio of this also we can calculate. So this is the value. You can see here. So for 6 cycles we have taken the RR maximum and RR minimum. 1, 2, 3, 4, 5, 6. You can see the 6 values. And this is actually the average value of all 6 values. This is average value for the all 6 RR minimum. And the ratio is 1.09. This is also normal. So this is also normal. So both the tests are normal. Any questions? For this before we have to do the zeroing. So without compressing, I will be keeping it on the table, and you will be seeing that there is some forces already shown, 17 Newton. I will be making it to 0. Once this is done, you are okay. Now we are recording the data. You can see the value going up. So, and this is the maximum. So we will ask this maximum first, and we will calculate that with the percentage. And here we are recording only the ECG. Ideally, if we have the beat-to-beat blood pressure, we will be also recording the blood pressure value. I will show you on recording how it looks like, so that we will not be able to worry about connecting the BP and pressing the start button for recording the blood pressure. So in this case, the blood pressure and the heart rate of ECG will be continuously recording throughout the study, and wherever we want to take the blood pressure or heart rate readings, we can easily take it out. But in this case, we have to, whenever we want, in case of isometric, we have to take the blood pressure 2 times before starting the maneuver, and during the maneuver, every 1 minute we have to take the blood. Zero Newton and 0%, and the is 0.2 and this is maximum 100%. Instead of Newton, I will be selecting it as percentage. So now if you see, here is maximum, which is around 100%, and this is about 0%. So now we will ask them to do the 30%. So 4 minutes for again, 8 and 4 minutes. Lot moving on, so అదే కాదు వేయండి ముప్పై కంటిన్యూస్ So we have taken one more BP now, 138 BP now.